Good morning, dear student. In previous lecture, we already discussed type first and type second superconductor. So, depending on the behavior of the superconductor in magnetic field, they are classified into two types: type first superconductor and type second superconductor. So, in this lecture, we are very much interested the effect of the magnetic field on the superconductivity or superconducting material. So we know that in the superconducting state, in the superconducting in the superconducting state, the material the material the material having zero electrical resistance electrical resistance. So we already discussed it, the relationship between resistivity and the conductivity. So whenever the material it is in the superconducting state, the material having zero electrical resistance, and it and behave behave as a perfectly behave as a perfectly diamagnetic material and behave perfectly as a diamagnetic perfectly diamagnetic material and behave as perfectly diamagnetic material. So below Tc, so we know that what is Tc? It is critical temperature. If you consider this is the first point, this is second point. So in the first point we discuss, in the superconducting state, the material having zero electrical resistance and behave as perfectly diamagnetic material, so it carries all the current. So below Tc, so below critical temperature, below Tc, if sufficient if sufficient strong if sufficient strong magnetic field is applied. So below critical temperature, if sufficient strong magnetic field is applied, the superconducting property of the material, the superconducting the superconducting property of the material reverse the superconducting property of the material destroyed the superconducting property of the material destroyed, and the material reverse back 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 to its normal state, to its normal state. So we're discussing the effect of magnetic field on the superconducting material. So below Tc, below critical temperature, if sufficient strong magnetic field is applied, then the superconducting property of the material get destroyed and the material reverse back to its normal state. In other words, if you see the definition of this effect of magnetic field, in other words, we can say that in other words we can say that the minimum field is required, the minimum field is required the minimum field is required to destroy to destroy the superconductivity. To destroy the superconductivity, the minimum field is required to destroy the superconductivity property. To destroy the superconductivity property is known as critical magnetic field. Critical magnetic field. Critical magnetic field, and it is denoted by symbol Hc. Okay, so critical temperature, it is denoted by symbol Tc, and the critical magnetic field, it is denoted by symbol Hc. So what is this critical magnetic field? The minimum magnetic field or the minimum field is required to destroy the superconductivity property of the material is known as critical magnetic field. The magnetic field at which, so the magnetic field, minimum magnetic field is required to destroy the superconductivity property is known as critical magnetic field. It is denoted by symbol Hc. The magnetic field at which the superconductivity property of material, the superconductivity property, the magnetic field at which the superconductivity property of material disappear is called critical magnetic field. It's called critical magnetic field. So these are the different definitions of critical magnetic field. So what is the first definition? The minimum field is required to destroy the superconductivity property of the material is known as critical magnetic field. Again, the magnetic field at which the superconductivity property of material disappear and it is converted into normal state is called critical magnetic field. So if you see the variation, the graphical representation for this Hc versus Tc. So Tc, it is your critical temperature, and Hc is your critical magnetic field, and then we get such a kind of graph. So we get such a kind of graph, and this area indicate the material is in superconducting state, and this indicate it is a normal conductor, normal conductor or normal state. So the area under the curve indicate the material is in superconducting state, it is perfectly diamagnetic, while the area which is not covered by the curve, it is a normal state. So below Hc and Tc, the material is superconducting state. So below Hc and below Tc, the material is in superconducting state, while above Hc and Tc, the material is a normal conducting state. So this is all about the effect of magnetic field on the superconductivity. So you should remember the definition of magnetic field, graphical representation. What is Hc, what is Tc? Tc is your critical temperature. So below Tc, the material is in superconducting state, but whenever below Tc we apply a strong magnetic field, then what happens? The superconductivity of the material get destroyed and it is converted into normal state. It is called as the effect of magnetic field on the superconductivity property of the material. So this is all about the effect of magnetic field on superconductivity. In next lecture we will discuss some important properties of superconducting material. Thank you.